So I'm Kyle Redinger. I'm the co-founder of Vivid Cortex. We are a startup based in Charlottesville, Virginia, and we do a lot of cool analysis on systems. I'm talking today about how we can beat Skynet, or the Terminator, in a very interesting part of our brain. So real quick, background, we do database performance management, and this means we measure all the things in 1 second granularity on the systems that we measure, right? This is a lot of data. Everyone in the room does a lot of data, but it also gives us a lot of insight about system performance. Right, but real quick, let's back up, and everyone's probably in the room because of this mandate, right? Your boss tells you manage 300 times as much data with 1.5 times budget and 1.5 times people. That's really challenging and really scary, and the more tools we have to solve this problem, the better we are. Well, as it turns out, our brains are some of the best tools we have. We all know that, but if you think about the mass amounts of data that we process up to 500 gigabytes of visual data per second, right? And our brains are very good about this. So we're going to do a quick psychological experiment. I have 2 data sets for you. I'd like you to spend some time finding the outliers in these 2 data sets. Okay, I'll circle them for you in 1 second. I'll give you a hint. One of them's easy and one of them's hard. Okay? So the one on the left is easy, the green, right? It had a clear, it was clearly different from the rest of the data set, and the one on the right was hard. Why is this important? Well, as it turns out, your brains respond very differently to easy and hard signals. An easy signal is always easy for you to see, right? No matter how large I make that data set, your eyes and your brain instantly know where the outlier is, okay? On the hard data set, it's a little bit different, okay? So as we increase the size of the set and we increase the distractors that our brain sees, we get increasingly worse at identifying that outlier, right? So the takeaway here is the more distractors we have in our visual system, the worse off we're gonna be. So where do we apply this? So a lot of you in the room probably use process controls, right? It's very easy to see around a mean where the outliers are with an upper control limit and lower control limit. It's very simple to understand, right? But not all data sets follow this normal pattern. What are some other tools we can use? Well, here's a real life example of a live production database server in 1 second intervals. It's a really weird data set, right? And we might want to know, as the head DBA or the head DevOps person, what's causing our CPU to spike? What's the root cause? Well, in a database, we have to look at the work the system does. At our company, the query is what we define as work. In this system, I have 300 classes of queries and probably 100,000 queries that are hitting that system. That's a lot of data, right? And that's a lot of machine learning to do in real time, right? So if I remove the time element and graph everything, right, it becomes apparent that in this data set, the blue class of queries is the obvious, right? There's clearly a relationship here. We don't need a machine to tell us that. So let's whittle that down and then zoom in and remove the obvious things that aren't important. And you can see there's probably 3 other really important query classes in this data set. Interestingly, the same thing is true if we cut down the data dramatically. So in this case, I take 1/10 of the original data points. So now comparing our brains to the machine, right? In the blue set of queries, right, we knew that there was a relationship there. And as it turns out, if we run machine models on this, we get statistical significance, and this makes a lot of sense for a machine. Okay, the challenge though is in these other things. So for instance, in the green set of queries, there's clearly some sort of bimodal thing going on. It's really easy for us to identify this, but if we run this through machine models that we haven't taught or assumed something about the data set, we're not very good at it. So the same is true of the other 2, right? They're not very model friendly. It takes us a whole lot of time to tell our machines to tell us what the difference is or if they're statistically significant, okay? So obviously this, we can't use our brains for everything. There's a big elephant in the room here. Actually, there's probably 15 in this data set. And the truth of it is that machines are much, much better than our brains when it comes to identifying outliers in a data set if we have a prior pattern to recognize, right? So a machine can do this really fast. I'd be surprised if anyone in the room could have done it as fast as the machine. So the key takeaways for you are use data sets, but use them smartly, right? Our brains do much better with less distractors, so eliminate them as best as you can. And with unknown patterns, humans are much better at finding signals than a computer. And it's a combination of the 2 that's going to help us win as our data load increases. So thank you very much. Remember, less is more. Feel free to follow up with me with more questions or thoughts. Thank you.